In our second lesson for Chapter 5, we're going to explore direct variation. A direct variation represents a relationship of a function in the form y is equal to kx, where k does not equal 0. The constant of variation for this direct variation, k, is the coefficient of x. This constant of variation also represents our slope. And another unique thing about this is that when it's graphed, the direct variation model passes through the origin. Let's see how that works. You're going to be given a statement that tells you that x and y vary directly. To write an equation for direct variation, first find the constant of variation k using an ordered pair other than 0, 0. That will be a solution to this equation. So you're going to be given a statement that says, suppose x and y vary directly with x being 5 and y being 35. We want to write an equation that relates x and y. Well, we can't do that until we find our constant of variation. And remember when we were talking about slope in our previous lesson, we talked about how slope is constant. So that's why constant of variation is also your slope. So the model of direct variation is y is equal to kx. Now we need to find that constant. So when we're given these two points here, or it's actually one point, it's an x and a y that fall on the line, we're going to replace what we know into this model and solve for k. And I find that k is equal to 7. So they're going to ask you to find the constant of variation, and the second thing is to write the equation that relates x and y. So that equation will be y is equal to 7x. And there is our equation. And it's an equation of a model of direct variation because x and y vary by this factor of 7. Now once we have this, we can find other points on this line. I might say find y when x is equal to -2. So if I do that, we'll just replace x with -2. We'll find out that when we input -2, our output will be a -14. That sort of generates some ordered pairs of some points on the line. Let's take a look at a couple of examples. You'll be given this statement again that says x and y vary directly, and they'll give you the conditions. We're going to be doing three things. We're going to find the constant of variation, we're going to write the equation, we're going to sketch the graph, which I didn't do in the first example. We start with our model, y is equal to kx. We know the value of y is 12. And we know the value in this example of x is -4. One inverse operation will get us the value of k. K is equal to -3. That's step 1. We found the constant of variation, and remember that's also my slope. Let's write the equation that relates the two, so we go back to the model and we replace k with our given value that we found in the first part of this problem. There is my equation that relates x and y. On to the sketch of this particular line. I'm just going to really do a really rough sketch here. All right, and I'm just going to show you that in the opening slide I mentioned an important topic of number 1, k is also equal to my slope, rise over run, and number 2, this graph will start at the origin. So my very first point, let me just change color so we can see, starts right at the origin. Slope is a ratio of rise over run, so I have a -3 as a ratio. It's over 1. I'll count down from that point, 1, 2, 3, and over 1. If I wanted to, I could extend it up, and then I connect those points, and there, oops, not a very good line, but that's the graph of this line. Okay, let's see if I can make that a little bit smoother. That's a little bit better. Okay. And then we could be asked to evaluate it. Let's try one more problem here. X and Y vary directly when X is equal to -6 and Y is equal to 9. Let's go through the same process. We start with our model, Y is equal to KX. We replace in what we know. We divide to get the value of K. K is equal to, and we always simplify, K is equal to -3/2, which again is also my slope. The equation that relates X and Y back to the model, replace K with the value that we found, and there is our equation of the model of direct variation relating these two variables. Let's do a rough sketch. We notice again we have a negative slope. So as I'm doing this, I'm going to always remember that my graph will start at the origin. And I will now see that my slope is a negative. So from this point down, I'll count down 1, 2, 3, and over 2. We only need 2 points to graph, and there is the graph of our line. As we're working on these, again, there may be additional components. The 3 steps are, let's find the constant of variation. Y is equal to Kx. Y is 4, and X is 8. Divide both sides, and I get constant of variation is 1/2. The equation that relates the two, Y is equal to 1/2. The graph will always start at the origin. This is a positive slope telling me to go up 1 and over 2, up 1 and over 2, and there's your graph. That additional part that I was referring to is sometimes they'll ask us to find Y when we're given a value of X. Remember, X is independent. I can pick any value of X, and Y depends on the value given for X. So we will take this -1/2 X, which is our model. We will replace X with -6, simplify. So when we input -6, our output was -3. And that's your model of direct variation.